My name's Leo and I'm a boat builder and a sailor, and I'm on a mission to rebuild and restore this 110-year-old classic sailing yacht, Tally-Ho. Now, planking is going very well and is ongoing and will be for a while. So this week we're going to be looking at something a bit different. We're going to be looking at Tally-Ho's engine and the choice that has to be made, some of the different options available, some of the different specifications and needs that need to be met, and finally the choice that I've made, why I've made it, and a bit more detail about how we're going to go forward with that. So you can see from the original Albert Strange drawings from 1909 that Tally-Ho was designed and built with an engine, so she's always had an engine. I did consider rebuilding Tally-Ho without an engine. There are some advantages, mainly hydrodynamics and weight, but after some consideration I decided it would be better to stick with the original design of having some form of propulsion other than the sails, partly for originality, but also because not having an engine would really limit a lot of the things I could do with the boat, especially if I ever want to use it for sort of educational purposes or anything like that. Tally-Ho's original engine was a Paraffin engine, and these were dual fuel internal combustion engines which would use petrol or gasoline to start off, and then they would switch to kerosene or paraffin once they were warm enough to actually burn it properly. These were very common in this era, especially in boats, because paraffin was cheaper than gasoline and it was also a little less combustible, so it was a bit safer to store. Tally-Ho's original engine was a 3-cylinder paraffin motor built by Smart and Brown in the UK. It was only 15 horsepower, which is very small for an engine of Tally-Ho's size. And according to the booklet that I found, that engine retailed at £105. Like many boats, Tally-Ho went through many different engines in her life, and that original paraffin engine was replaced in 1920, 1926 and 1932. Each of those years she got a different engine. They were all paraffin engines, and the last one in 1932 was a 4-cylinder Thornycroft, and that remained in the boat for a few decades, and it was in the boat in the 50s when the boat was cruised around the Atlantic by a family, and a woman named Fran Flutter, who was a little girl when they did that Atlantic cruise, wrote about the cruise, and she wrote about the elderly petrol paraffin engine causing issues throughout the cruise because it was so unreliable. Later on, Tally-Ho would have had diesel engines fitted. She may have gone through several diesel engines, I don't actually know, but it seems quite likely. When I got the boat, it didn't have any engine inside it at all. But because of all these changes, and because Tally-Ho's early engines were so unreliable, I don't feel any need to try and be authentic with my choice of engine. I don't think I need to go and find an original 1910 paraffin engine, because even if I could find one, it would be extremely unreliable and probably quite dangerous. Using a very combustible fuel like petrol and kerosene in a boat isn't really a good idea, which is why almost all boats these days, the inboard engines at least, are almost always diesel. So making that choice means that I'm free to really consider what would be the most practical and the best solution for the boat and for how the boat's going to be used, without being constrained by sort of historical significance.
I can hear it here, like usual.
You okay there?
We got it! We had to get these rivets out. The hole through the floors was not quite big enough, so the rivets were getting caught up in it and we couldn't get them all the way through. So the holes in the floors were drilled to 5/16, but we're gonna drill them to 21/64 so that they're just slightly bigger, and that way the clearance through the floor is good, but the clearance through the frames is just as we originally had it at 5/16. So, stupid chicken. I'm having my moment.
So reliability is one of the most important things to take into account when considering different engines. And personally, I feel like if you have an engine that's unreliable, it's actually more dangerous than not having an engine at all. Because if you don't have an engine at all, at least you're not going to be expecting it to start and then find out that it doesn't. My previous boat had no engine and I sailed it for many thousands of miles and across the Atlantic. And when you do that, you have to be extremely careful and you sail the boat in a very different way. You keep a much greater distance from lee shores and you plan things more and you're just more cautious. When you have an engine, if it's unreliable, you can be lulled into a false sense of security, and then when that engine doesn't start, you can end up in real trouble. A moment ago, I mentioned a lee shore. To explain that, if you imagine that you're standing on a boat and the left-hand side is the port side, the right-hand side is the starboard side, but as well as that, you've got the weather side and the lee side, and that can change depending on where the wind is coming from. But if the wind is coming from your left onto the port side of the boat, then you would call that side of the boat, everything to that side of the boat, you would call to weather. And everything to the other side of the boat, you would call to lee, or in the lee. And so if you're on your boat and you see a piece of land over there where the wind is blowing towards the land, that would be on your lee side. It would be in your lee, in fact, and it would be called a lee shore. And that would be a very dangerous thing because the wind is blowing you towards that land. And if you're not able to navigate your boat away from that land or alongside it, parallel to it, you'll eventually be blown onto that land and your ship will be wrecked. So that is why a lee shore is a sailor's worst enemy, really. When you're out at sea and there's no land around at all, there's not that much to worry about, apart from capsizing and sinking and being pitch-poled and sharks and giant squid. But the real dangerous thing is the lee shore when you get to land and you can be blown onto the shore. If you see land on the other side, on the weather side, where the wind is coming from, then that is much safer. That land then is sheltering you from the waves, from the seas, and if the wind blows you and you can't navigate your boat any other direction, it will blow you away from the land, and so you'll be safer. Now, the reason I'm talking about lee shores is that if you're stuck on a lee shore, that is the time and the place where you need your engine to be reliable. And if you don't have an engine at all, you're less likely to be there in the first place. But if you have an engine and you end up there and then you find that your engine will not start or will not work or it's not strong enough to push you against the wind, then you're in real trouble. So that's reliability. Simplicity is also very important, being able to maintain your engine easily with materials that you can easily carry with you. An engine, I think, should be as simple as possible so that anybody with the instruction booklet and a little bit of knowledge can do a pretty good job at fixing it and maintaining it. And that brings me on to the good old-fashioned diesel engine, which is a remarkable thing. And although modern ones do have some electronics, fuel injection and so on, at its core the diesel engine is a very, very simple beast, and there's not that much that can go wrong with it that can't be fixed fairly easily with fairly rudimentary tools and skill. And especially when you're out in the middle of nowhere, you know, maybe you're somewhere in high latitudes or anywhere away from infrastructure, that's really important that you are able to fix and maintain your engine. So a diesel engine is a really good choice for a sailing vessel. The other advantage of a diesel engine is that the fuel supply is very predictable, it's very consistent. So a diesel engine is a pretty good solution for a sailing vessel, but it does have its drawbacks as well. Obviously, diesel is not an energy that you can generate on the boat, so you do have to go into port to get diesel eventually if you run out. It's also very loud, it's smelly, it's polluting. It makes vibrations that are not good for the boat in the long run. So there are drawbacks to the diesel engine, but it is a very tried and tested and understood, trusted technology that is simple and reliable.
I'm getting some bolts ready for this staircase we're working on. The scaffold wasn't accessible enough for the chickens or the dog. So yeah, ladders apparently are really hard for dogs. We need stairs at the front of the boat because it's hard to go up the ladder with a plank or a bucket of ship soup.
As well as the diesel engine, there are various other fuel alternatives, of course, some old, some new. I know a few boats with petrol engines in, gasoline engines. In fact, I know one guy who built his own boat, and he had a van while he was building the boat, and when he'd finished building the boat, he just took the gas engine out of the van and put it straight into the boat, and it's still there, complete with the dashboard from the van with all the dials on it and the ignition key. But on the other end of the spectrum, electric energy is becoming very popular for marine propulsion, and there's a lot of very obvious advantages to that. It's a clean energy, it doesn't create pollution, it doesn't smell, it's quiet, it's very efficient. It really does make a lot of sense. But of course you do have to think about where you're getting your power, and with a long distance cruising vessel there's only so many ways you can do that. Obviously solar and wind turbines are a couple of ways you can do it, but a lot of vessels actually have diesel generators to generate the electricity to power the electric motor, which always seemed to me like a bit of a long way around of just having a diesel engine. I think a fully electric boat makes a lot of sense in a scenario where that boat is able to charge from shore power regularly, such as a ferry or a day boat. But for cruising boats, I've always been quite cautious of it, partly because of that factor of where do you get your energy if there's no sun and there's no wind and so on, but also because the technology is fairly young and, more importantly, quite complicated, at least for a simpleton like me. And I've always believed that on a cruising boat you should always carry enough materials, parts, and also experience and skills to be able to fix anything on that boat which might go wrong, because when it does go wrong it will probably happen in the most remote location possible. Now, bear in mind, I'm not an expert in any of this. I'm simply approaching it as someone who has spent some time at sea and knows the importance of simplicity when things do go wrong. For instance, you're offshore, you haven't slept for days, the conditions are terrible, the boat is rolling around, you haven't got the right tools. It can be very, very difficult to fix a problem which would be easily fixed ashore. And so it's so important to make sure that things are as basic and straightforward as possible, and also to put in as many systems of redundancy as practical. For instance, on a small boat that might just be you go out with your outboard, but you take a pair of oars with you as well in case the outboard breaks. On Tally-Ho, the engine itself is a backup anyway, because the sails are the main form of propulsion, but that backup needs to be as simple as possible to operate, maintain and fix, and if possible that backup needs a backup as well. So in episode 86, I talked a little bit about how the stem is sagging away from the boat, just very gently, very slowly. The post was sinking into the ground, and so I pulled it back into the boat using this big post that I put up between those deck beams, and I come along over the top of the deck beams onto the stem head, and that pulled it back so it was touching the beam shelf at the top, the beam shelves. We do really need, though, to actually bolt the stem through the breast hook that is attached to the beam shelves just to hold the front of the boat together. The lower one especially is hard because the hole has got to be drilled from the inside of the boat for a start, because we've already got this hole in the bronze, so it's got to line up perfectly with that. But on the outside of the boat, especially on this lower hole, there's going to be only a very, very narrow landing area where the bolt has got to come out, where the hole has got to come out. So obviously in a long hole that you're drilling in a large piece of wood, there's a good chance for the drill bit to wander away from the line that you're drilling. It's a bit tricky, but it has to be done, so we're just going to go for it and hope for the best. Okay, so drilling these holes went really well in the end. I did spend a bit of time making sure that drill bit was really sharp and really straight and getting some good marks to aim off on the centre line. But there was some luck involved as well when you're drilling a long hole. So it was a good relief that these ones, especially this lower one, came out dead centre, because if it had come out on the side, it would have been a pain to deal with and to plug it up properly. It wouldn't have been fun. But anyway, it's done now. Pete has already counterbored both of these holes, so that's just these bigger holes which are going to take the washer and the nut for these 2 bolts. All these counterboards eventually will be filled with hardwood plugs, I think, so there obviously won't be these big holes here when the boat's finished. And I'm going to be making some filler pieces which are going to go in between the breast hooks and the angle that's created by the stringers on this lower breast hook and by the beam shelves on the upper breast hook. There's a void there basically in that gap. There's going to be a bolt going through it, and that's just a place where sort of debris and detritus could build up. It's not going to be very accessible, so it won't be easy to clean. So sort of place where things could build up and then catch water, contain moisture, and then that could be a place that rot could start on the end of these big structural timbers. So it's better just to fill that with a solid piece of wood, and we're going to bed that in there. We'll probably drill through that filler piece before we bed it, do a dry fit, drill through, make the hole for the bolt, then bed it in, then drive the bolts in and do them up, and then the stem will be completely self-supporting, and we can get on with planking again. Right, Pete.
Okay.
What's going on?
We are just as we speak releasing the stem. No, we finally got our upper breast hook fastened to the stem here, all the way through. Got a little block in there. So the beam shelf is now officially strapped and bolted to the very front of the boat. And so we no longer need this big come along to hold the weight of that stem. It's all that bolt's doing all the work now, along with the beam shelf and the breast hook. So we're just gonna take this down. It's in my way because of planking, so I'm happy to move it.
Look at that, no gap. If I get the right camera angle, there's no gap.
There's like a little teeny gap on the bottom, but that's like okay. It's fine.
Now, in considering an engine for Tally-Ho, which is going to be situated right about here, I had always been convinced, for better or worse, that a diesel engine would be the most practical and reliable solution, and really the most safe in terms of navigation. And ever since I've been thinking about diesel, I've always been very drawn to a company called Beta Marine. Now, they're a UK company that marinizes Kubota engines. Kubota engines are Japanese, very simple diesel engines. They're used in a lot of machinery, they're very reliable, they're new, so they don't come with any of the problems and headaches of an old engine and where you don't know the maintenance history, but they are very simple, there's no electronics, and they have a very, very good reputation. And one of the reasons why I was enthusiastic about these particular engines is that they have been used by many of my friends and colleagues in their boats in the UK. Lots of traditional boats, for instance, all of Ashley Butler's boats, a lot of Luke Powell's pilot cutters, boats of a similar style and size as Tally-Ho, run and owned by people with a similar mindset to me, tend to have these engines and have very good experiences with them. I've also been considering the amount of electricity that I might need. Now, in my previous boat, I had a very, very simple electric system. It was just one cabin light, one masthead light, and a bilge pump. and a speaker, and that was it. And it was all charged off a tiny solar panel and a tiny car battery. But things have changed since then in my life, and I, for better or worse, do use technology more now, and filming and editing these videos is a big part of my life, and I would like to continue doing that. And there's various other reasons why having a good electricity supply on the boat would be very useful, not least for using power tools. So we were looking at ways of equipping a Beta Marine engine with a very big powerful alternator. An alternator is just the piece of the engine which generates the electricity from the movement of the engine, and the big powerful one would then be able to generate enough electricity, hopefully, to power all the systems that we need on board. And while researching this, my engineer Dirk-Jan in the Netherlands came across a system which uses a Beta Marine engine and modifies it very slightly to become what is called a parallel hybrid system. Now, the principle of this system is that the diesel engine, the gearbox, the prop shaft and the propeller is all unchanged. The whole drive chain is exactly as it would be on a regular engine. And that's really important because that means that will always work regardless of what happens with the rest of the system. But on this system, instead of having a regular alternator, it has two very large, we'll call them alternators for now, because one of their main functions is to generate electricity from the turning of the engine. And they're connected pretty much directly to the prop shaft. So when the prop shaft turns, the generators spin and they generate electricity, a lot of it very fast, which is then stored in battery banks. Now, the clever thing is that these alternators aren't really alternators. They could be described as generators, but they're also electric motors, which are essentially the same thing in reverse. But the point is that when the diesel engine is turned off, the electricity that has been stored in the batteries can then be sent back from the batteries to these electric generator motors on the engine, which can then turn the prop shaft, turn the propeller and move the boat around without using the diesel engine. So that's why it's called a parallel hybrid, because these two systems work next to each other rather than in line with each other. And what that means is that there's double redundancy, essentially. If the electric system fails for whatever reason, the diesel engine and the drivetrain will still work completely as it should do. But also, if the diesel engine was to fail, or if you ran out of diesel, or there was some kind of other problem, if you had power in the batteries, the electric system would also work and would be able to run the prop shaft and the prop and move the boat around for a limited time. Now, apart from this really important safety factor of redundancy, there's also several other advantages of this sort of system. It's important to remember that this is a sailing boat, and so most of the time the sails are going to be used for moving the boat around. But there are going to be a lot of times when you just need to use some propulsion for a short amount of time, and in those situations an electric propulsion system would work very well. So, for instance, when coming in and out of harbour, coming up onto and off of the dock, where you really just need a short amount of time on the engine before or after you hoist your sails or drop your sails. During these times, the engine wouldn't need to be started, and it also wouldn't need to be left running idle for a long time, just in case you need it. That electric power would be there and would be accessible very quickly. Say if you're coming right onto the dock under sail, and you want just that backup of being able to put the boat in the stern for a few seconds to stop yourself if you misjudged it. Often when people do things like that, they'll have the engine running the whole time, but maybe never even use it, or just use it for a few seconds. It could be on for half an hour. It also means you can do these maneuvers in peace and quiet, which is just really nice. You know, something like sailing onto the dock or sailing on or off the anchor is a really nice experience, and it's made slightly less nice when you have to have a diesel engine chugging away the whole time and blowing smoke out of the boat. The system also means you can generate a lot of electricity really fast. We worked out that to generate enough electricity for a day of general appliance usage at anchor, you would only have to run the engine for about 15 minutes. This means that you can have a lot more electric appliances on board. You know, if you wanted to, you could have a fridge freezer, you could have a toaster, a kettle, you could have a bloody washing machine if you wanted to. That also means that there will be enough power to film, to charge cameras, to charge laptops, to make videos and all that stuff. So it really could help make it possible to make videos like this after the boat is finished and is sailing around. Of course, the battery bank will often be charged by running the engine, but it can be charged in other ways as well. It could theoretically be charged from solar panels or from shore power if you're tied on the dock and plugged in, or, and this is really exciting for me, it can be charged by regeneration through turning the prop shaft. And what that means is that if you're sailing along using the wind to move the boat, the water rushing past the hull will turn the propeller if you set the propeller in a certain way, because it's variable pitch. So the propeller will be turning as the boat's going through the water, the engine's off, but that turning prop will run these generators and generate electricity. So you're converting the wind power that's moving the boat through that movement, through the propeller, into electricity. And so if you were on a long offshore passage, for example, doing a lot of miles every day, you could generate enough electricity from that movement to completely power all your onboard needs, and you wouldn't actually have to start the engine at all, therefore saving all that diesel in the tanks for if and when you actually need it, therefore making the boat more efficient, more sustainable, and more economical, and quieter. But really the thing which convinced me that this was the right system for this boat is that redundancy, the double redundancy, and the fact that the diesel engine can work whatever happens. The electrics could just completely go haywire and I might not have any idea how to fix it, but the diesel engine is still a diesel engine. It's still connected to the gearbox and the prop shaft and the prop, and that will work as normal. And so there's a much greater reliability there, and that is the most important thing about this system. If the diesel engine fails, you have that electric system as a backup, and using that regeneration from the prop, by the time you've sailed to wherever it is you're going, even if your batteries were empty when your engine failed, by the time you get there they could be full enough to have that bit of power that you need to get into port or to get into shelter somewhere. Now I have looked quite closely at real world examples of this system, people who have used this exact system in their boats, and there has only been very good feedback. Now, like any system, there are drawbacks to this system, and the two drawbacks really that I can think of is the weight, so the weight of the extra components, and the batteries in particular. The batteries can be lead acid or lithium ion. Lithium ions are a lot less heavy, so those are more preferred, they're more expensive. And there are lithium ion batteries which do not heat up, because the ones in the cars and mobile phones do have a tendency to explode sometimes, not very often, but the sort you put in boats would be the sort that they don't heat up, they can't be explosive, they're a lot safer. So that's one downside. The other downside is just the cost. This is a very expensive system, and the battery is a big part of that expense, as well as the whole hybrid system in general. But like everything with this project, I'm determined to try and make the choices that result in the best quality long term, and I think that this system will be looked back on by myself and hopefully by other future owners of the boat as a really, really worthwhile investment. Well, I realise there's been a lot of talking in this episode and not much doing, so I hope it's not been too boring, but there have been a lot of questions about the engine, and so I hope this has answered some of them. We have been working really hard on the planking all week, and we'll get back to that in the next episode and show you all the progress we've made. Now, choosing the engine for Tally-Ho was always going to be a little bit contentious because it's something that everybody has an opinion on. Lots of people know about engines and have their own ideas about the systems they like and the systems they don't like, and I don't think there's any choice I could have made which would please everyone. I know some people might feel that the choice of a hybrid diesel electric system isn't fitting for such a traditional old boat, but I would say that, you know, although this project is very much about appreciating tradition in some ways and looking back to the past, it's also very much about looking forward into the future. And you know, this boat isn't going to be a museum piece, she's going to be a working sailing vessel, and she's hopefully going to bring a lot to people all over the world in various ways, which I'm not even quite sure of myself yet. And I'm confident that this solution is going to enable Tally-Ho to be reliable, practical, traditional, but also relevant and a little more ecologically sound for many decades to come. All right, well, I've talked a lot of rubbish today, so I think that's about it. But thanks a lot for watching, and a massive thank you to everyone who's donated or otherwise supported the Tally Ho project. It does make a huge difference, and we really could not do it without you. So thanks so much. I really, really appreciate it. I'll see you next time. Cheers.